Welcome to our UG students. Now I am going to discuss regarding the JAM question solution 2020 in the organic chemistry, and this is also helpful to that of the NEET and JEE guidelines. Now I am going to our first questions for the JAM 2022. Here the carbonyl group is reduced to the corresponding alkane in presence of the carboxyl group. This is the chemoselective reduction of the carbonyl group in presence of the carboxyl group. Here the different type of the reducing agents are given in their options, but which one is the correct options? From that problem, it has been shown that the different type of the reducing agent, that is the lithium aluminum hydride, that can reduces the carbonyl group as well as the carboxyl group. Here the lithium aluminum hydride has greater reactivity, so it can reduces the carbonyl group as well as the carboxyl group to give the corresponding alcohol. But the sodium borohydride has lesser tendency for the reduction of the carboxyl group. It has lower reactivity, only it can reduces the carbonyl group to the corresponding alcohol. And this is the chemoselective reducing agent, the boron TH3 in presence of the THA. It only reduces the carboxyl group in presence of the carbonyl group. And here the given problem is that the carbonyl group undergoes deoxygenation to give the alkene, and the deoxygenation can take place in presence of the Wolff-Kishner reductions or in presence of the Clemmenson reductions. We know that the acid sensitive functional group, in presence of the acid sensitive functional group, the Wolff-Kishner Clemmenson reduction does not take place, such as if we take that of the beta hydroxy carbonyl group, the zinc amalgam HCl, the corresponding alkane is not formed, that is the decarbonylation reaction is not occurs. Rather, the alpha beta unsaturated carbonyl compound is formed by the reaction with that of the more acid sensitive functional group, hydroxyl groups. But in presence of the Wolff-Kishner reduction, we know that the Wolff-Kishner reduction is very sensitive for the basic mediums. In the basic medium, it can deprotonate the carboxyl group, so the carbonyl group is not deoxygenated. So our given problem is that the chemoselective reduction of the carbonyl group, that is decarbonylation in presence of the zinc amalgam HCl will occur. Here the Wolff-Kishner reaction is not take place. The sodium borohydride can reduces the carbonyl group here. Lithium aluminum hydride can reduces the both carbonyl and the acid groups. Boron can reduces the carboxyl group. Or here the zinc amalgam HCl, the Clemmenson reduction is the appropriate reagent for this transformation for the carbonyl to alkane. And this is the different reactivity of the different functional group. Various type of that is the aldehyde group is more reactive and the acid group is less reactive in presence of the different type of the lithium aluminum hydride reducing agent, sodium borohydride, and these problem is very important for the chemoselective reduction of the different functional group. This diagram is taken from that of the Cladon books, and from this book it has been shown that the different type of the reducing agent is represented here, and from this different type of reducing agent it has been shown that the red color means the compound can acting as the reducing agent, but the black color is not properly reduced the substrate. So the sodium cyanoborohydride only can reduces the imine groups and the aldehyde groups and the ketone group, but it cannot reduces the ester, amide and carboxyl group. Sodium borohydride can reduces the aldehyde and the ketone group, and ester group is not reduced, very slowly reduced, but the amide and the carboxyl group is not reduced. Lithium borohydride can reduces the aldehyde, carbonyl, ester group, but the amide and carboxyl group is not reduced. Lithium aluminum hydride is the only reagent that can reduces the all type of the functional group, and the boron BH3 can reduces the boron can reduces the carboxyl groups very fastly compared to that of the other functional groups. And this is the transformation where the amide group can convert it to that of the alkane in presence of the BH3 and THF. Here the ester group is remain intact. The mechanism for the amide to alkane is that the amide first coordinated the boron compound and to give that of the is a reactive pieces, and then the hydride ion additions to give that of the alkane. Here the ester group remain intact. This is the chemoselective reduction of the carbonyl group in presence of the ester group. And this problem is very interesting, and this problem is come in different type of the competitive examinations. Here the ester group and the carboxyl group both are chemoselectively reduced. In presence of the lithium borohydride, the ester group is reduced, but the carboxyl group remain intact. In presence of the H+, the alcohol and the carboxyl group undergoes lactonization to give the one of the product. Another is that the boron can reduces the carboxyl group in presence of the ester group. The ester group remain intact and produces in presence of the H+, it gives the lactone derivatives. And the dival means diisobutyl aluminum hydride, chemoselectively reduces the lactone derivatives to lactol, and it undergoes isomerization to give that of the aldehyde and alcohol. This is the very interesting chemoselective reduction in presence of the dival reagent. Now I am going to that of the hydroboration reaction that will also come, that will also come in the 2002 JAM examinations. Here the chemoselective, here the deuterated boron is used for the reduction of the alkene, and this is the stereoselective reduction and the hydroxylation reactions. And we know that the deuterium and the boron boron capture occurs in the 4-member cyclic transition state, and this is the syn transition state, and the deuterium and boron come in the same phase, and we get after the in presence of H2O2 and NOH, hydroxylation take place, and the deuterium and OH group come in the same phase. So the option D, deuterium and OH in the syn side, is the correct option. That is the B option is the correct. And the similar observation also observed in the different type of the boron chemistry, where the boron group, this problem will come taken from that of the Cladon group, where the boron can coordinated with that of the alkane to gives the BH2, and then after hydride addition we get that of the 9-BBN, and this 9-BBN means 9-boro bicyclononane, and this compound is very reactive for the selective chemoselective hydroxylation of the different type of the alkene. And now I am going to that of the alkyne. In the alkyne chemistry, this is the secondary amyl borohydride, and this secondary amyl borohydride is very reactive for the chemoselective reduction of the alkyne system, and the boron group is attached to the less inner sides, and the hydride is attached to that of the more inner phase, and the syn addition will take place, and after the hydroxylation the OH group come here, and after tautomerization we get that of the aldehyde compound. That is the secondary amyl borohydride is used for the chemoselective oxidation of the alkyne to aldehyde. Now I am going to that of the next problem, that is the amine group. Here the amine group is coordinated to that of the boron, and after the alkyl migration we get that of the cyclic amine compound, and this cyclic amine compound is very much enantiomerically pure, and this is very important transformation in presence of the B2H6. Now this is the problem was come in the JAM examination from the orthothalaldehyde. This is the thalaldehyde, and the intramolecular Cannizzaro reaction will take place in presence of the NOH. Here the hydroxyl group is added to that of the carbonyl to produces the carboxylate anion, and the hydride minus ion is attached to that of the same molecules, and we get that of the one is the alcohol and another is the carboxylate anion. So the option A is the correct. Here this is the important reaction for the pentaerythritol preparation, where the acetaldehyde in presence of the excess formaldehyde gives the pentaerythritol derivatives in presence of the formaldehyde, and the last step is that of the hydride addition to that to give the pentaerythritol. Now I am going to that of the oxidation reactions. In the oxidation reactions, the chemoselective oxidation of the aldehyde group to that of the carboxyl group take place. Here the chemoselectively oxidize the silver oxide and the ammonium oxide in presence of the different type of here the manganese dioxide is used for the oxidation of the allylic alcohol, and this is the manganese dioxide mediated oxidation of the alcohol to give that of the carbonyl that can react with that of the Wittig reagent to give that of the alkene derivative with the trans conformations. Next is that of the Schwann oxidation, where the DMSO in presence of the oxalyl chloride in triethylamine, it gives that of the alpha beta unsaturated aldehyde, but at lowering temperature minus 60 degree it gives that of the allyl chloride. Now this is the mechanism for the Schwann oxidation, where the alcohol can convert it to that of the aldehyde, and this is the opener oxidation, where aluminum isoperoxide converted the alcohol to that of the carbonyl compounds. Now this problem video will come in the next week. These are the problems. This will be discussed in the next week. Thank you.